So, quick question. How many of you folks are familiar with what Spark is? Anybody use it on a day-to-day basis? Yes? No? Okay. Okay. Just wanted to get a sense. Okay. So who are we? I am a management consultant at Invisium. I apologize for those Cowboys fans out there. I'm a lifelong Redskins fan. Jet?
CEO at Invisium, do a decent amount of Scala development. As you'll notice today, all the examples are going to be in Scala. Really big Scala fan. So.
Okay. So, what is Spark? Spark is a open source, general purpose cluster computing framework. Spark was developed at UC Berkeley's AMP Labs and was later donated to the Apache Software Foundation. And I believe in 2014, it was named a top tier Apache project. So at a very high level, what does Spark do? Well, so if you think of it this way, Spark pulls in data from various sources. It pulls in these data sets. Now, once the data sets are within Spark, it changes them into what's called resilient distributed data set, or RDB for short. You can give Spark instructions on what manipulations need to be performed on these data sets. Spark takes those instructions, performs the manipulations, and spits out the results. Now, how many of you are familiar with Hadoop? MapReduce, yes, somewhat. Okay, so Spark is similar to Hadoop, except it has significant advantages in the form of speed. The reason is Spark performs its functions in memory, inline streaming, versus Hadoop, which has to read on disk batch processing. To give you an example, if Hadoop needs to perform a multi-step computation on something, it needs to read data from the cluster, performs the function, writes it back to disk, then reads it again, performs the function, writes it back to disk. Spark, meanwhile, can do all of that all at once and spit it out. So you can kind of see that there's definitely significant speed advantage with Spark. Really quickly, so that diagram at the bottom, it shows the core components of Spark. We're going to go over a couple of these in the presentation. Some of the things to kind of take away for the API, depending on which version of the API you're using, you'll be able to use R, SQL, Python, Scala, or Java. On the top right, there's the mlib, which is the machine learning library, as well as graphics. I don't think we're going to be talking about graphics and mlib too much. Just worth noting there. So, why do people use Spark? Well, Uber is a huge consumer of Spark. Uber uses Spark to solve problems near real time. So, and I know this is going to be a really unpopular example. Uber uses Spark to be able to optimize their pricing so they can adequately implement surge pricing. I apologize, I know. They also use it for being able to optimize the location of their drivers. So say, for instance, they determine that there needs to be a redirection of drivers to a specific area during a time of day in a given city for XYZ reasons. They use Spark to be able to compute that type of information and give that intelligence to drivers. They also use it for being able to process client payroll purchasing information to be able to compute this huge amount of data to be able to pay out their drivers and payroll pretty much the very next day. There is a link, YouTube talk on theirs. It's really fascinating. If anybody has time, I highly recommend watching it. So let's talk a little bit about healthcare. Spark really seems like a natural fit for healthcare. So right now there's healthcare providers out there that are using Spark to be able to ingest historical medical information about their customers. They're then able to apply intelligence to that and determine if there's anything odd happening, such as insurance fraud or anything along those lines. Furthermore, IBM is a huge contributor to Spark. So IBM open sourced their, what's the name of the library again?
SystemML.
SystemML, which is their machine learning library to be able to use with Hadoop and Spark. In addition to that, Spark is being used in the IBM Watson's Health Cloud. Is anybody familiar with what the Health Cloud is at all? I mean, it's huge, right? I mean, the Health Cloud is used by everybody. It can be used by anybody in the health industry, from providers to doctors and technicians. It's pretty awesome stuff. In addition to that, they're also investing heavily in their people, training them up on being able to develop Spark applications and offer Spark as a service to their clients. So in addition, the last couple examples are like Netflix and OpenTable. Netflix and OpenTable are able to take in your typical usage information, compare that against their millions of clients, and be able to suggest restaurants in OpenTable's case based upon similarities and where you visited. Same thing with Netflix. They're able to recommend movies or TV shows based upon your preferences, cross-referenced against the other users that they're taking a look at. So, real-world Spark architecture here. So, when you're architecting a Spark application, Spark on itself is not able to do a significant amount. It's really reliant upon the entire Apache ecosphere. So in this diagram, you can see Kafka and you can see Cassandra. There's a whole bunch of other stuff that just completely out of scope of this presentation. When you're architecting your application, you really have to be careful and take a look at and consider from a security perspective what the security posture of all these components are, the configurations, et cetera. So for instance, is your data secure that's being passed back and forth from in and out of Spark? Is there any sort of strange, is there any chance that there's some sort of serialization issues that are going to happen? What about SQL injection? So there's Spark SQL. So there is a possibility, if you're not careful, that there's a possibility of a form of injection that can happen. Furthermore, what about data persistence? So for those of you who are in the medical industry, or for those of you who work in the federal government, you're working with classified data or with HIPAA data, where is your data going? Where is it being stored? Where is it being read from? All of this information can potentially be sensitive, get mixed with data that is not supposed to be there, get written to disk, and then you have a huge policy violation. Furthermore, what about encryption? So are the components, is the communication between the components and Spark encrypted? Is the encryption native, or is it something that's like a bolt-on that could be problematic or error out for some weird reason? These are all things to really consider when you're building out a Spark application. So this is an example of Spark cluster mode. So basically, applications are submitted to the driver program through a Spark submit script. Jack will go into Spark submit script a little bit later in the presentation. Spark applications run as independent sets of processes on a cluster, and they're coordinated by the Spark context object in your main program, which is also called the driver program. Data cannot be shared across Spark applications or Spark context instances without first persisting it. So that basically means that if you have two Spark applications within Spark itself and the processing, you can't share that data. You have to have it persist elsewhere before you can share the data. Spark Context connects the cluster manager, which is the thing in the middle, and it can be built. So Spark Core has its own cluster manager, but you can feel free to use Apache Mesos or Hadoop Yarn if you'd like. If you're already using that, or if you're transitioning over from Hadoop, you can use that as well. The cluster manager is responsible for allocating resources across the applications. Once Spark Context connects to the cluster manager, Spark requires the executors on all the worker nodes within the cluster over there. The executor is the process that runs the computations and stores the data for your application. So since the data can't be shared across Spark applications, each application gets its own set of executor processes. The takeaway from this, I guess, the slide, is really that the power to Spark is really how everything is handled in memory. You can kind of see across the cluster there, the cache piece, and that is distributed across all of the Spark nodes so that it's shared. And it's also, by design, designed to work in highly distributed environments. So this is just a basic chart of exposed ports and services within Spark when you spin it up. So the things to take, the things to note here are the web UI is launched on 4040, and it's Jetty based, so the application runs on all network interfaces. Kind of an issue, right? Even in standalone mode, it does that. So that's something to be really careful about.
Cool. So let's take a look at an actual Spark application now. And hopefully the code's okay in the back. If not, I'll just talk through it. So here's an example of a really simple Spark application. So in this particular model, we're actually doing streaming. If anyone's familiar with Kafka, in this scenario, we're hooking up to Kafka. So kind of the concept is we get a message off of Apache Kafka, right, within a topic. We send that over in stream mode to Spark. We do some real-time processing of that, and then you can spit it back out somewhere. So for sake of argument, you could load it potentially into Cassandra, anything JDBC, really any external storage, right? So kind of the pattern is you're going to get some data. You'll do a series of transforms on it, right? So one of the unique things about Spark as opposed to Hadoop is you actually have the ability to do things in multiple stages, right? So map and reduce in a map reduce world is a little bit more linear. As opposed to what you can do in Hadoop, within Spark rather, which is you can do multiple stages of transforms on that data, right? So you get some of the performance speed up, obviously, because it does a lot of it in memory. And it also uses serialization really, really heavily throughout Spark. We'll talk about the serialization and I guess the own issues it brings to it. But one of the things Spark relies very heavily on is serialization and deserialization of data. So that's our Spark application. The key things to take away from there is we create a context, which in this scenario is a streaming context. We do a little bit of configuration, and then we hook up to something, receive data, and transform it, right? So the Spark context, you're going to always have one of these in every pretty much application. You can have one per JVM. You can do multiple, but it's really, I can't think of many reasons I've ever had to go that route. You also do things in there, for example, adding files, adding jars to the environment. You basically upload to that object. And there's other things you can do with those files. For example, you can invoke scripts, which we'll see later on. But generally, when you're looking at Spark, you'll look at the Spark context as the central entry point for the app. And as Abdullah alluded to, it's going to start up a web UI on 4040. So that can be fun. So we mentioned the concept of resilient distributed data set. So a resilient distributed data set is essentially the abstraction that Spark's going to use. So think of a scenario where you take a list, right? Maybe you split that list up, or you have a bunch of JSON and you parse that out. So think of a list, maybe you have 1,000 members and you want to do something with that. So Spark will let you essentially parallelize that stuff and then work on that in parallel. So RDDs are essentially the abstraction you're working with there. So basically, on the other side, there's a scheduler, right? So this is just an example here of what actually happens. So you'll make an RDD, then you're basically going to do something, which essentially becomes the sink at the end. You can see much more complex graphs than this. So for example here, this is what Spark ultimately does. So there's essentially two phases, right? It creates a logical plan, and then it creates a physical plan where it actually does the work. So if you recall, Spark is one of the benefits is distributed, right? So it's really important to understand who has cycles to do things. So the first step you'll basically see is it'll create the logical plan. It's just essentially the flow of how it's going to go through the transformations in the series, et cetera. One thing you'll notice is that there's multiple sets of RDDs. RDDs are an immutable, basically, structure. They're read-only. So essentially, whenever you're doing things on RDDs, and say you're doing multiple stages of transformations, it's going to create a new set of RDDs at each one of those stages, right? From a security perspective, the significance of that is certain types of things are going to result in, for example, things like disk persistence, right? So if you can see over there, you see the thing that says shuffle right in the middle. So whenever you're going to do a shuffle with resources, it's going to basically trigger some kind of persistence to happen, right? So depending on the data you're dealing with, right? If it's HIPAA data, maybe you don't want that data to ever get basically persisted to disk, right? So it's important to kind of understand within the life cycle what's actually happening with your data. The other thing too is because there's really it's not that linear. You may consider that at certain stages you might have different data. So it's kind of considerations that you have to really think about that kind of in a stage-wise manner. Once it creates like a logical plan, it creates a physical plan. So that's basically how it's mapping to resources. So basically, those are kind of the two stages there. So, but the logical plans where all that stuff's built out. In terms of disk and memory storage, so Spark has a few different ways. Particularly, it's the memory storage and disk storage that you kind of deal with. So each of those levels there kind of dictates something, right? So none, as you guys can imagine, means basically like kill that off. Disk only means basically it's going to do all the persistence on disk and just ignore memory. You can do memory only, which means like you don't store it to disk. The serialized aspect, or just put basically asterisk, underscore serialization, and basically that means like you're going to persist those things as serialized objects the entire time versus just raw data. With regards to off heap, so that's one, for example, has anybody ever heard of Alluxio? Does that one sound familiar? So basically there's lots of different tools that you could use to kind of extend the fault tolerance of something like Spark. So one of those particular is Alluxio. So basically imagine you have stuff held in memory in Spark and like something dies, right? One of your workers unexpectedly dies. So something like Alluxio will let you actually have some redundancy. But so basically by saying off heap, it means it's going to be stored off of Spark's heap. It's going to be stored in another heap. So the consideration there is now you have another pretty much life cycle to deal with your data in, right? So if you push something like Alluxio, it's literally just going to have like a warm cache of everything you're doing. So think about that when you're basically persisting that data off heap. You just have another place where your data is going to end up. With regards to disk persistence and encryption, there's really not a lot native to Spark at this point. Seen some interesting kind of projects. IBM had one where they were basically building in encryption on the fly into their serializers and deserializers. So basically, when you're persisting those serialized objects, you're doing it in a safe manner. That's really cool, but that's not obviously something that's in like Spark upstream. If you are using Spark with HDFS, you do get a little bit of protection in the form of I/O encryption, but that's really specific to if you're using HDFS and Yarn. If you're not using HDFS and Yarn, then you don't get that. But there are a couple places I mentioned where that data gets potentially cached. One of those is to be explicitly called checkpoints. The other is shuffling. So shuffling is basically the process of where just think about how your jobs are going to move without your cluster at really high level. Another way is basically if you run out of RAM. So recall that Spark is, one of the benefits is being in memory. So once you run out of memory, you've got to store that data somewhere, right? Because you're always going to be queuing stuff up, right? So somewhere you have to persist that if you don't want to lose it when you run out of memory. But one of the things to really consider there is just like what kind of data are you combining at each of those stages, right? Really important to know what kind of data you're acting on at any given time. So like I mentioned, if you're in Yarn mode, then you can basically turn on I/O encryption as a setting. If you're not using Yarn, then just completely ignore that, right? Just out of curiosity, who uses Spark with Yarn in here versus Spark with something else? Anybody do Yarn mode in here? No? Cool. So let's talk about Spark SQL. So Spark SQL is probably one of the coolest things about Spark to me. It's really powerful, really, really powerful, but there's lots of areas that are ripe for research. So for starters, Spark SQL is kind of a little bit broader than just SQL. It works as more of an abstraction and lets you work with a lot of different underlying data formats. So you can work with traditional JBC, JDBC, Hive, and HiveQL, JSONs. Anybody deal with Parquet files or anything like that? But then you can deal with other things. For example, you can pull stuff in from S3, right, and basically work on that. So it basically lets you create, essentially structure out of your data and then query against it. So it doesn't have to be native SQL, but allows you to basically query anything like you would in SQL, right? With regards to how they do that, so pre-2.0 Spark was a lot different. In 2.0, they introduced basically Catalyst. So Catalyst essentially works on basically a grammar for SQL that lets you basically kind of see what the base language looks like. And then it basically does lexical analysis on that, and does all kind of magic to basically create, and in the end, it spits out actual bytecode with SQL. So in the end, it's doing code generation based on a lot of different things. This one I think is good, kind of illustrates why you should give a shit. So open, right? But down there and reading in, and I'll read it for you guys. If it's simple, quoting sounds good. This really isn't a SQL injection problem since it will be up to the callers to sanitize inputs from an external source. And Spark's not something you would expose directly to external calls or input. Still, this may be a void corner case problem. So blah, 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 blah. Who can tell me what's wrong with that thinking up front? Anybody? I'm sure you guys have been doing security for a while, right? Is that a good approach to kind of protecting people through a framework? Debatable, right? Oh, welcome to that. Apparently that's on. Sorry about that. But just basically illustrate. So in terms of the things you're pumping into Spark SQL, you really got to think about that. This is kind of how it works from start to finish, maybe extraneous, but essentially at the end, you can kind of see you're actually spitting out actual code and generating code on the fly. Here's just an example of like the base grammar, right? So you can see there's SQL-like things and tokens. So basically from there, builds out basically abstract syntax trees and stuff like that. But the things to kind of take away from there, for example, rules, conditions, and their bodies can contain arbitrary Scala code. Gives Catalyst more power than domain-specific languages for optimizers, right? So anytime you get into the mix of basically generating code based on things, magical things can happen. This is an example here. So this is if you're doing things in the kind of the Spark way. Has anybody ever worked with like LINQ or anything like that, or I mean anything that lets you do a nice, language integrated way of querying things, right? So you get a lot of benefits to that. You get things like type safety, etc. But that's an example, just kind of what it would look like if you're doing, basic data frames in Spark. And here's an example of basically what each of those gives you, right? Data sets are actually 2.0 and up. It's mentioned there. Data frames with the Spark way of doing things, 2.0 and up, it's you're working on data sets. But basically, in terms of like your code breaking, essentially in 2.0 and up, it just basically aliases data set. Just here's an example of what you get. Basically, do you get compile time checks? Do you get runtime checks for these things? Which is obviously important if you're basically doing a lot of dynamic SQL, building things on the fly, making a lot of assumptions about the underlying data. So here's an example here, right? If you're doing Spark SQL, you can do plain old SQL, because everybody seems to love falling back to that. You can do it just fine, it works. You guys know SQL, nothing new to learn here. If you're working with a data set, then you can actually work with a little bit more complex of a workflow there. But things to point out, so you do get some type safety and verification, but essentially you are still spitting strings in there, right? So things to kind of think about if you're familiar with how SQL injection works. So classic anti-pattern there, right? Anybody spot the problem, win the prize, right? So pretty vanilla SQL injection there. But the things to kind of think about underneath, like what does Spark actually do for you in that regard, right? Because you recall that slide a couple back where they're like, it's up to you, right? So what does Spark actually do for you? And the answer, it does a couple things actually. So if you're using JDBC RDDs, this is how they escape your SQL. So if you can see at the bottom, you can see basically replace, and it'll take a single quote and it'll basically double up the quotes for you. Maybe that's interesting, right? So if you're basically working on, securing it, or say you're a pen tester and you're trying to basically do evasion types of stuff, right? Things to consider, that's exactly what it's going to do. It's going to double up on your single quotes, right? Additionally, it also does some other stuff where you can basically substitute in variables. And here's just kind of the regex they run up on top. But basically the caveat there is that they'll attempt to do some things, but you also have to basically work with within the constraints of the syntax they want you to use. So the things you got to basically take away from that is if you're basically developing for Spark SQL, you should definitely care about SQL injection. There's not 100% safety built in. Just kind of considerations. If you read the documentation, they don't mention a lot about SQL injection. In fact, I think it's almost mentioned, well, I think it's actually 0 times if you read through the Spark SQL section. If it's not 0, it's maybe 1 mention. Like SQL injection could happen, right? So things we basically know about SQL injection apply here, right? In terms of you don't have a native way to do binding things, but maybe you think about basically the data that you're allowing in. So in the mention back here from the developers and the framework folks, basically people aren't generally talking directly to Spark, right? So think about like in a traditional, MVC kind of application, right? Where you submit something to a web form and it, gets basically, processed by something on the back end, right? It calls out to a database, and you kind of know the kind of flow, right? It's somewhat synchronous. But in a Spark SQL world, you may not actually be passing that from a client, right? So you think about the kind of concept of maybe that's part of some kind of analytics thing that happens, right? So you care about user behavior. User clicks on something, and you send something off and said, well, hey, user clicked on this thing, right? So watching user behavior, trying to predict how they're going to behave. So there's lots of scenarios where data is actually going to get into basically a backend Spark SQL query, right? So, and the interesting thing there is, you may have like second order, third order, fifth order, right? Essentially, you're going to be taking that data and essentially working iteratively with it, right? So you can introduce potentially malicious payloads at each one of those stages, right? So if you're doing things dynamically, you should really think about how that's running through Spark SQL, right? But like it says there in the base of the second bullet point, so if you're just basically banging on the scanner and looking for it to do something for you, you may not actually ever see anything back. So if you're trying to do the traditional tricks, if in a JVC world where it's like, introduce like with a benchmark or something like that to kind of spit out a little bit of time delay, you may not actually see those things back, right? So if you're just banging on a basically site with a dynamic scanner, and just kind of banging the hammer into that nail again and again, you may not come up with anything. So it makes things like timing attacks really hard. So there's other subtle ways you're obviously going to see those things, like if, for example, if jobs start to fail or like the cluster drops, right? Something's going on. But it's not quite as easy, just basically dynamically to figure these things out. Because you may not ever get a call back, right? Spark works in streaming mode, but you can also do things in batch mode, right? So that batch job or whatever is going to happen. It's going to start maybe without any user input or anything like that, right? It may just pull data, maybe untrusted data in for those jobs. User never has a way to interact with that. So considerations if you're actually like trying to manage this and actually detect things as they get introduced in your environment. User-defined functions is another thing. So a lot of databases support these, and Spark supports working with user-defined functions as well. So at the end of the day, that's Scala code, right? So you're essentially introducing Scala code into SQL, and then it's basically operating on your code when it's basically doing compilation. So as you'd imagine, a user-defined function can introduce some interesting things. But because it doesn't actually work through the traditional way, it doesn't go through the full optimizer or the validation, everything like that. So proceed with caution in terms of introducing like user-defined functions into your apps. So we'll talk about Spark and serialization a little bit. So any of the 80s kids in here, that's Glass Joe. He's got a weak jaw. You hit him once and he basically drops, right? So Glass Jaw and for Glass Joe. So Spark uses serialization pretty hardcore, right? So we like speed. People do things like machine learning, predictive analytics, real-time stuff. It's all about speed, right? You don't want those things to happen slow. There's a lot of missed opportunities. In a scenario, think about the one he basically described with Uber. Those real-time jobs equate to like real people driving around in cars and stuff like that. So it's really important that those things happen fast. We don't have a lot of delays. But at the same time, Spark makes a lot of intelligent assumptions with regards to what those serialized objects actually are, right? So Spark uses Cryo as a default serialization library. So Cryo is a really cool library. It does a lot of interesting things. It allows you to basically serialize non-serializable objects, stuff like that. So there are, fortunately, without just basically saying, oh my god, it's hopeless, you can actually turn on basically for registration. of classes. And basically what ends up happening is if you turn that on, which is set to default false, you turn that on and then Spark will actually, or Cryo will actually do type registration for respective types that you're passing around. The TLDR is that you make it a lot harder to actually fool the serializer into invoking something that it shouldn't invoke. So some of the things you kind of run into with these kind of attacks, right? So essentially if you have stuff on the class path, right, you can potentially invoke that through serialization kind of attacks, right? So there's some good research out there. I can't cite that I created all this stuff. The links are up there, including just the code to kind of run the test cases here. But the basic gist is that if you're not doing those things, you can potentially, pass serialized data in, completely fool Spark into executing things that it wouldn't necessarily want to execute, right? So anything that's available on the class path potentially can be invoked, right? And you can do things like, for example, abuse zero-argument constructors to make it easier. You could also call things like finalize methods, right? So if you guys are familiar with what probably happens in things like finalize, right? You do cleanup, you delete files, you blow away resources and stuff like that. So it can be pretty nasty in a runtime environment. Here's an example. Again, I did not write this. It's cited at the bottom. And that's probably impossible to see there, but just in this example, you're actually basically sending a serialized object across the wire with the intention that you're actually basically going to crash the JVM because you're basically clobbering memory at that point. So there's a lot of, I'd say, ripe areas within the framework without kind of pointing out any specific ones. A lot of interesting research to probably do in this area for Apache Spark. And I'll leave it there. So another thing we also have is the pipe command. So we'll talk about that. And little piranhas eating at your feet. So Spark allows you to pipe things through invoking things with Process Builder. So it allows you to basically, invoke processes, invoke the shell. So you can call like -c if you want. Additionally, you also can invoke external files. So we talked before about uploading things within the Spark context. So if we're doing like add file, for example, if we do add file in that way, and we upload, say, our code, or we upload a Python script or stuff like that, now we can actually pump data through Spark as it's received. So think about if we're streaming that data, we can take that data and we can pump it directly into Process Builder to invoke processes, or we could also pass that into external scripts, right? Can anybody think of anything bad that could happen there? I don't know. So here's an example here, just basically creating, and this isn't real code, this isn't particularly useful, but just to kind of illustrate to you guys how that works, right? So first thing we do is we take a list and we're just breaking that up, right? Nothing too fancy there. And, but regardless, you can see what it ends up doing there is it creates a parallel collection. So that's kind of the magic there, is now whatever we want to do on those respective pieces of that list would be parallelized, right? So kind of cool. But then from there, we can basically do data.rdd pipe. And so we're not actually passing the data in. It's a kind of a bullshit example, but it kind of illustrates the point. But we can pass whatever we want in at that point, and it's ultimately that's going to pass out to Process Builder, right? So Process Builder lets us spawn up one process at a time. And on the bottom, right, you can see what happens when we actually do a collect. So think of collect when you're like in a MapReduce world, and collect is like kind of like your reduce. You basically pull in any data down that's being operated on the cluster, and you can work with it. So that's kind of the parallel over to like reduce, right? So there we do collect, and we actually do something with the data. So things you could obviously do, right? So you're passing it to R, you're passing things to shell scripts, you're passing things to Python scripts, right? People love to basically run eval on shit. And I don't know why people do this, but they really, really love to run eval on untrusted data. So I'd basically say if you're pulling stuff into other scripts, really, really think about basically what you're allowing to just basically. So if you're doing like a straight eval on, I can't offer you any hope at that point, other than just to not do that, right? Things like invoking the shell directly, right? Things like, for example, understanding the data. So if we're passing off into Python, right? It's important to know basically how it's going to handle our data. So depending on what you're actually using, R, Python, just important to understand the context of what you're passing it into and how that data is going to be handled in a safe or unsafe manner. If you're just doing straight static analysis, well, obviously, you're probably going to miss what that sync eventually ends up being, right? Because you're going to pass out of the JVM into something else, right? So considerations that if you're just relying on pure static analysis, then maybe you're going to miss stuff when you basically pass off into a Python script. just kind of a caveat there. With regards to transport layer security, so does anybody else get pissed when people call stuff SSL these days? Like SSL is dead, and like every time somebody says that, just shut them up and remind them that TLS is the way to go, right? It's just bad to say that. So there's obviously a lot of places that you're going to want to secure communications coming from Spark, right? So think about overstreaming interfaces when you're actually interacting with your databases, right? Spark basically from master to workers within respective, blocks and stuff like that in the block manager. There's all these different places where you're going to potentially pass unencrypted data around, right? So kind of without going too far off, Spark actually uses in some scenarios like Akka as its underlying layer to basically do some of that distribution. And it's basically TCP-based communications, right? So as you guys would all imagine, it's probably important to encrypt our communications even behind the firewall, right? We've been through this dance before. So by default, Spark, you can see the default there is nothing, right? So you don't actually get any encryption. With regards to the block transfer service, you've actually got to basically do some of the steps at the bottom to do any of that stuff. But basically, just kind of think about what you're plugging Spark into. And I know people, a lot of development shops we work with, they're like, we don't want the performance kit of like encrypting things behind the firewall, but I just say, do it. Authentication to Spark, so a bunch of different ways you're going to authenticate to Spark, right? There's a REST API for submitting things, so if you want to submit to the REST API. So as you'd imagine, you'd probably want to secure that, right? Make people authenticate. I mean, the basic gist is if you're submitting jobs to Spark through the REST API, ultimately that job is code, right? So basically you're essentially injecting code at that point in a way, right? So anything you're going to be able to run, you'll potentially be able to run arbitrary code on a Spark cluster. So probably important to set some kind of authentication around that. And additionally between nodes, right? So you can use like pre-shared, basically shared secrets between nodes and stuff like that. But it's probably a good practice also too to make sure that the nodes have to authenticate because obviously you can imagine if they don't, then you can trick them into doing evil things. It's also important between all the different stores. So if you're using like Spark and like EMR and stuff like that, and you're using on AWS, well, like you can use like AWS's like IAM, identity access stuff, and like it kind of makes your life a little bit easier than what Spark basically offers out. So Spark, as we mentioned, basically creates that web UI, right? Anytime you create a Spark context. So this is one we basically run it in standalone, but it looks exactly the same in cluster mode. So you can see, obviously, what jobs have run. You can do all that stuff. You can see some of the data. So you really, really want to protect that, right? Does anybody disagree with that? It's behind the firewall. You want to protect that? Okay, protect it. So by default, you're not actually requiring authentication. So one of the things you can do, which is kind of ugly, is you can use like a servlet filter if you want to basically build that in yourself. It uses Jetty pretty much as basically the container. So here's an example, and it's like impossible to see from back there. Nothing magical if you've ever seen like a servlet filter before. It's literally just basically checking username, pass, and can check off somewhere else. So you can put your own identity, but that's kind of the way you do it if you're using it out of the box. But I'd encourage you to definitely make sure you're requiring some authentication. With regards to authorization in Spark, so in the UI, you can set ACLs with regard to who can see certain things, who can do certain things. If you're giving your developers, data scientists access to the UI, I'd probably encourage you to give them exactly what they need, not let them just basically have carte blanche. Apache Ranger is really cool, allows you to basically do a bunch of stuff with a little bit more granular authorizations. Without talking about it, check it out if you're really interested. It's a Hortonworks thing. RDDs, as we mentioned, are basically immutable and read-only, right? But the thing to kind of take away from that is, so in a scenario where, imagine that your Spark RDD corresponds to like a Kafka partition, right? Is anybody familiar with Kafka? Okay, so basically Kafka is a big commit log, right? So it allows you to, as you get things, so it works great in the streaming world. So imagine something happens in an event, right? Kafka just basically can broadcast that out. So it works on basically subscribers and producers. So you essentially can, send messages to basically a lot of different places, right? So Kafka works with basically topics, And the unique thing with Kafka compared to something like Rabbit, has anybody worked with RabbitMQ or any common like MQs? So the nice thing about Kafka is that they also let you partition things within those topics. So you can have people consuming things at different speeds within those partitions, right? So you can have multiple, say people subscribing to a topic, but they can basically consume those at their own speed, right? So you can do in that scenario where you can have, a topic per user, a topic per, or partition per user, partition per sub-function, right? So the thing with that, though, is that's actually going to basically correspond to like an RDD, right? So the scenario there is like, so you've implemented authentication and like, basic authorization, from the other end of Spark, right? But at the same time, like, do you actually know who's published into those topics, those partitions, right? So some scenarios you've seen where you can use, insecure direct object reference like behavior to talk to certain partitions. So kind of doing a threat model of Spark. So imagine you did things right at Spark, but you kind of screwed up with the things that are talking to Spark, right? Just kind of things to think about when you're actually processing that data, and things to think about as you're basically securing that ecosystem, right? So kind of summing it up, you really want to think about Spark and basically all the things it plugs into, right? From the framework, which includes the core, GraphX, MLlib, and Spark SQL, right? But then you think about all the common players that kind of plug into Spark, right? Your data stores, everything like that. This defaults, right? So as you can see, like they don't really turn on a lot of protections out of the gate, so it's important to kind of know where those are and obviously plan around those. And really think about, so we see a lot of, and the way we basically kind of using Spark is in a microservice world where everybody spins things up really fast, doesn't obey proper data contracts and stuff like that. So it is important to kind of understand the data, the context of what's coming in, right? Am I getting that from a trusted source, or did somebody basically make me parse a JSON file from where I didn't expect it, and now that job's going to take like 1,000 times longer, right? Just considerations as you're building your application, especially if you know your application better than anybody else, the threat model of that application, just things to really think about as you're developing. And that is the end of our show, folks. So happy to take a little bit of Q&A if anybody has anything. Going once, going twice. Sold. Thank you guys for your time today.